Hello, everyone, and welcome to Innovate to Build, Model the Future. And this session is titled Building Smarter, Robotics, AI, and Green Innovations Reshaping Construction. I will be your speaker for this session. My name is Mark Petrucci, and I'm an ACC Technical Manager. I went to school to Rochester Institute of Technology, where I received my degree of Bachelor of Science in Civil Engineering. I then worked for a general contractor where I acted as a surveyor as well as project engineer. I then moved to a design firm where I was both a CAD manager and IT manager. And finally, I moved to a much larger firm where I was a director of technology as well as a BIM manager. Some of the skills or certifications I've received over the years. In 2022, I was Autodesk's Technical Collaborator of the Year. I am also an implementation certified expert as well as a certified instructor. And I'm proud to say that I'm also an inventor where I hold 2 patents that were sponsored by Applied Software during my time here at Applied Software GRAITEC Group. As far as GRAITEC was founded in 1986, and it's an international group comprising of 50 offices in 13 countries worldwide. And we help construction and manufacturing professionals to successfully achieve their digital transformation. With over 700 employees, GRAITEC is a developer of high-performance BIM applications, as well as an Autodesk Platinum partner in Europe and in North America. In today's session, we'll talk a little bit about terminology, what's real, what's not, and then we'll look at specific trends happening in the AEC industry related to robotics, augmented reality, virtual reality, artificial intelligence, and then finally we'll finish up with any Q&A. So let's first discuss terminology. So as far as terminology, let me talk to you a little bit about what we imagine. When it comes to robotics, we think of these highly advanced robots that look a lot like us, that can do many things that we can do faster, stronger, and so on. When we talk about AR, when we think about the movie Iron Man, in there many times Tony Stark can see holograms, these objects, computer-generated objects floating in space, and he's able to interact with those objects. In VR, show I used to watch many years ago, Star Trek, there was a holodeck where you walk through a door and then you can create whatever environment you want. So you are now inside of a virtual environment. And finally, with AI, this is probably the newest term that we've all been hearing about lately. And we think of this artificial intelligence that can do all these things better, faster than what we can do. But in reality, robots may not look like robots you think. Here's a device that I've used many times, a robotic total station. Some of you may have a vacuum cleaner in your house that goes around your house and vacuums for you. Those are all different types of robots. For AR, we can't do like in the movies where we see a hologram and we can touch it and interact with it. With AR, we do need some sort of a device that kind of overlays the digital world onto the real world. And typically we're going to use some sort of a lens that will overlay onto the real world. With VR, the most common example of VR has to do a lot with gaming, and where we can actually put on this headset and now we are in a completely different environment. And so we don't even see the outside world. We're completely immersed in a virtual world. Then as far as AI, many of us should have or may have experience with ChatGPT and OpenAI. In fact, I use ChatGPT occasionally, and I'll explain to you, when I use it and why I use it. But let's jump into robotics and see how robotics can impact the AEC community. So the first thing that we'll talk about here, the advantage of robotics really is the repetition and the precision that it offers us. And in this case, if we think of robots that are constructing items, for years, robots have been involved in the manufacturing process. robots were used for a very long time in the manufacturing of cars, for example. You know, how many cars are sold, and they're all built pretty much the same way. Maybe a few different options, but the wheels, the steering wheel, the body, they all go in the same place. Well, with buildings and robots, we can utilize robots to help us create buildings much more efficiently than what we can do today. And when it comes to sustainability, there's a lot of waste that's involved during construction, and taking advantage of robots can help us do that. So we'll look at a study where we're going to take a look at a 3D printing robot. Now, 3D printing robots have been around for quite a while. I actually have a 3D printer myself. It's not that big. I don't use it to print out a building, but I do use it to print out things that I model. So if we can model a building, why not use a robot to construct the building for us? But some of the advantages of using the robot, I already mentioned a few, but let me just summarize again. There's speed and efficiency. You know, robots can work faster. They could be very efficient in their movement. Um, very, they're very cost effective. There is that price for the actual robot, but once you invest in it, then it will pay for itself very quickly. Not only that, sometimes with the robots, we could take advantage of customization that and design freedoms that we don't have without robots. Because many times things are too expensive to achieve without the robot, or too difficult. And so customization and design freedom is very helpful when it comes to robots and AEC. And I've already mentioned the fact that we can reduce waste. Another thing that I forgot to mention was increased safety. You know, by putting robots in situations where normal human beings might be at risk, the robots can definitely help us with safety. And then, as I said, with sustainability, you know, we're able to use locally sourced and sustainable materials, coupled with the reduction in waste, and that will help us with sustainability. But let's look at a real example when it comes to robots. Now, I'm first going to show you my personal experience, and that's dealing with robotic total stations. And on the left-hand side are some examples of different robotic total stations. The one that you're going to see in the video is this one right here. Now, I really did not walk around with this type of robot. Okay, I actually walked around with a human being, but I was training the superintendent at this particular project on how to use the equipment to help better determine proper layout for this building. So let me go ahead and play this recording. This is Project Amelia. It's a home in Florida that the homeowner wanted to use a robotic total station to verify layout. So the entire home was generated inside of Revit. And then using the robotic total station, we were able to locate all the underground utilities. And it was a good thing that we did that, because there were a couple places where the pipes coming up and the floor mounted electrical units were not, the electrical boxes were not in the correct location. And so using the robot, we were able to quickly find those locations. Now I'm going to jump back into, I'm going to jump right back into the video and proceed right to here and just stop for a second. So this is the robot. And what you see is I'm back here holding an iPad, and that iPad is communicating with the robot. This robot is actually telling us where to stand. And by looking at the iPad, we can walk around to wherever a pipe stub up might be, or an electrical box. So we're not telling the robot where we want to be, it's telling us where we need to be based on the model that we're using. Well, I talked about 3D printing. Let's actually see an example of a 3D printer. Now, so here's one I found on the internet, and they're designing some buildings. In fact, they use this 3D printer to design an entire neighborhood. Now, when you look at this, you know, this does not look like it's big enough to do that, but let's take a look at this video and you can actually see the unit. Here, it's actually constructing these buildings out of concrete. And once the walls are created, then framers will come in to go ahead and create the roof, install the roof trusses. But here's an example of the actual printer. And it is going through and it is actually placing concrete down on top of itself over and over again. And these will actually be the physical walls for this particular building. So those of you that are out there that work with concrete a lot, a lot of this can be done um, differently. We can put rebar in there as well. But what you're looking at is a 3D printed floor plan taken directly from a three-dimensional BIM file or Revit model, and then from there it's converted into a 3D house. All right, so now let's talk about augmented reality. So what is augmented reality? I found this picture. I thought this is a good one. This pretty much shows a man that he's got a screen across his eyes. And what it's doing is it's displaying a model. And using his fingers, he can actually move parts of the model around. And so he's actually interacting. He's taking a virtual model that's shown on the screen, and he's also interacting with a 3D model to see how the two will overlay each other. So first, what is the definition of augmented reality? It's a technology that overlays digital information, such as images, videos, or 3D models, onto the real world, enhancing the user's perception of their environment. Number two, some advantages with it is spatial awareness. AR devices are spatially aware. They know where they are in a building. And this allows users to interact with and manipulate virtual objects in the context of the physical world. The AR goggles today can sense if there's specific objects around it and then have the ability to overlay the digital with the real without any need of any sort of targets to do that. Then as far as applications, an AR presents a massive opportunity to capture inputs and utilize them when relevant, particularly in architecture, engineering, and construction. And we'll take a look at that in just a minute. So what are the benefits of AR as far as with architecture, engineering, and construction? Well, definitely enhanced visualization. It allows designers and builders to view their compositions as discrete layers of data and real-world construction, including structures, massing, MEP, HVAC, and more. Where I see this used mostly is with MEP and HVAC. We walk into a building and where they're constructing new MEP and HVAC systems, you can put on some lenses or bring up an iPad and you can see how it's supposed to be laid out in a particular area of the building. Improved competence. Studies have shown that students who used AR technology were more competent in identifying tasks and understanding complex construction processes. If you think about it, looking at a floor plan, especially when it comes to MEP, it's often difficult to try and imagine or visualize the ducts and the pipes and how they all interact with each other. But again, with AR and putting on the goggles, you can actually visualize how that is supposed to be constructed. And then with AR, it has access to BIM. It enables users to access building information modeling, BIM files, on site, integrating the 3D design software such as Revit with the real world construction. So we all know that the design models, everything starts from the design model. If things don't fit in the design model, they're not going to fit at the job site. So pretty much everything fits in the design model, or at least we make it fit in the design model. Now, that doesn't necessarily mean it's going to fit at the job site because obviously construction technique is important. However, though, we can better visualize and communicate design intent when we get into construction. Let's talk a little bit more about how AR can help out in engineering. AR aids in construction planning by overlaying digital blueprints onto the physical construction site, and it enables engineers to access the feasibility of designs. Equipment maintenance. Okay, we don't think about this that much, but with equipment maintenance, engineers can use AR for equipment maintenance. They can access real-time information and visualizations to streamline maintenance process. So what does that mean? Let's say that we've got a mechanical room, we've got equipment in there. I could put on my AR goggles and I'll see the equipment. At the same time, I'll see a heads-up display that shows me information about that equipment. And if I've got that tied into my building's FM system or O&M system, I can actually read specific information about that piece of equipment, maybe how much power it's using, or the airflow, or the flow of fluid through a particular area of that equipment. Wherever the sensors are, I can view that sensor information on my heads-up display. Then as far as quality control, AR technology can be utilized for quality control by allowing engineers to overlay design specifications onto physical components for accurate inspections. So let's talk about augmented reality. All right, I showed this image before, and I said this wasn't realistic. Okay, and that's because we can't just simply display a hologram in space. What's more realistic is we're always wearing goggles. So in each of these different views, we are looking at a real world environment, but we are wearing goggles so that we can have both the digital world and the real world superimposed on top of each other. By the way, in the upper left-hand corner, you'll see the person wearing a helmet with some AR goggles, and it looks like he's watching a video of a man talking. I actually used similar AR goggles back when COVID first hit. I had AR goggles at my home. My wife had talked about adding a room on the back of our house, and as much as I communicated to her that there wasn't enough room, I designed it in Revit, and then together we went outside and we put on the goggles and we were able to view the space or the room on the back of our house. And from there, we were able to see that it was just not enough room to fit that room in our backyard. Physically, would have fit absolutely, but it really would have interfered with just everything in the backyard. That together, we both decided that we would not do the room. And one last thing up here in the corner here, this shows a very common AR set of goggles that is by Microsoft, and it's Microsoft HoloLens. I got a video here that's going to show you my first experience with AR. And if I remember correctly, this was back in 2012, and this is up on my YouTube channel. But in here, I just quickly put in some equipment in a Revit model. And then I pushed the equipment over into a product that Autodesk used to have called Showcase. And with Showcase, I put a sheet of paper underneath the furniture, the same paper that you're going to see that's sitting on my desk in a minute. There's my hand, actually. And this is my very first attempt with AR. And so there's the paper. And now notice as I move that paper around, I can actually see that model. Now with my naked eyes, I can't see the model. I have to look through it. I have to use a lens. And in this case, I was using a webcam, but I could have used an iPad or a set of goggles if they were available back then to view that three-dimensional object. That is augmented reality. I was displaying that furniture on my desk. And in a real environment, it'd be much bigger and I would display it on a floor so I could see how things look. But that's an example of AR, digital plus the real world. You actually can do AR today. You can do it right after this call. Now, we can use iPads and iPhones, and we can display 3D models. Like in this example, you can see a model displaying on the desk. Now, you need a model to do that, but you have the ability today. In that case, if you happen to download the Amazon app, and many other furniture companies and appliance companies are doing this, they have the ability that when you look at their, let's say, furniture online, you have the option to display it in your room. And in that case, you press a button and you hold your camera up. This camera will actually show your physical room, and then you can see what that piece of furniture looks like in your room. So you can actually do that today. But in what we're speaking about today, when we're talking about engineering, architecture, construction, good example here, using an iPad, I'm able to point this up towards the ceiling, and from there, it's showing me where the duct should be, and then it's giving me specific information about the duct. Okay. This is a great example on the right-hand side where AR is extremely helpful when you can't see behind specific objects. We can't see through walls. We can't see through the ground. Well, using AR, I can now see where all the underground utilities are related to the particular area that I'm in. That is not just a photo. If I was to take this iPad and I happen to move it right or left, it would constantly update and show me the pipes that are under the pavement. Virtual reality. So we just got done talking about augmented reality. Now let's talk about virtual reality. So what is virtual reality? It's a computer-generated simulation of an environment that can be interacted with in a seemingly real or physical way by a person using special electronic equipment, such as a helmet with a screen inside, or even gloves fitted with sensors. Now, it kind of sounds a little bit like AR, but hang on as we continue here. VR is an immersive experience. The VR technology creates a fully immersive experience, transporting users to a digital environment that can be manipulated and explored. So with AR, I'm actually overlaying a digital environment onto the real environment. With VR, I don't see anything with the real world. I am now inside of a digital world. And applications in various industries. VR, it's not just limited to entertainment. VR, most of us or many young people are more relate VR to gaming. Many games that people can buy where they're inside of an environment and they're fighting pirates or bad guys or zombies, or maybe they're walking, planks that are high up above the ground, so they kind of feel like they're in danger. Well, VR, it's found other applications, other uses for VR, including around architecture, engineering, and construction. As I said, it is an immersive design review, and you'll see a video which will show you a good example of it, but it allows for architects and engineers and clients to virtually walk through a building design before groundbreaking ever takes place and experiencing the space and making informed decisions about design elements. So we're able to walk through a building that doesn't even exist by using VR. As a result, we could take advantage of real-time design changes. And I'm going to show you that in a video that I have, where architects can make real-time changes to the design in a VR environment, and they visualizing the impact of the modifications on the overall aesthetics and functionality. And finally, client engagement. With VR presentations of architectural designs with enhanced client engagement, we provide an interactive and realistic preview of their proposed projects. It is so common for people today, especially when I worked at a design firm, where as much as the architects would design buildings and spaces for customers, they were adamant about certain areas of the building. And as much as we communicated on how things would feel or the flow of it, sometimes the clients trusted the architect, other times they were set in how they wanted the building constructed. Only later that during construction that they realized that the space doesn't feel as big as they thought it would be. If you've ever experienced walking through a new construction where you have all the wood framing put up but no drywall, you walk through the space, it feels bigger. It feels bigger, but once you install the drywall, all of a sudden everything feels smaller. And so we're able to get that feeling, if you will, by walking through a virtual model. As far as the tools, I already mentioned that we need like a head-mounted display. So a very common one, such as Oculus Rift. That's very common. My son has that. A lot of people have that mainly for game playing, but Oculus Rift can be used for, you know, reviewing models. HTC Vive, I I actually purchased one of the early HTC Vive units, and you'll see a video I created where I'm actually using the HTC Vive goggles. Now the thing about the HTC Vive, at least the early versions, those were wired. I had to be plugged in. The Oculus Rift was wireless, so there were some advantages with the Oculus Rift, but again, that was a later technology that wasn't available in the early days. As far as the different platforms, there's multiple platforms out there, but Unity and Unreal engines, they provide tools for creating and visualizing architectural and construction projects in VR. You have the ability actually to interact with the model and also have it automatically update the models inside of Revit if you decide to do that. But the big thing here, which I hope that you'll see when I show you the video, is the remote collaboration. VR technology enables remote collaboration, allowing stakeholders to participate in design reviews and project discussions from different locations. Remember, if we have a building, why not invite multiple people inside of that building at the same time where we can all see and talk to each other? So we're going to take a look at that. But a couple other benefits related to, to VR is VR simulations. They're used for training construction workers in safety protocols and procedures, and they create realistic environments for practicing safety measures. Remember, if we create this environment, people put on the goggles, they're in a completely environment, we can control everything that happens in that environment. And so it's a great place for construction workers to practice specific safety protocols and procedures, or even just the order of construction. Project planning. Construction teams use VR to plan and visualize construction sequences, logistics, and site layouts, optimizing the construction process. We could actually link in VR, we can actually take advantage of project schedules, where now we can watch the building constructed, in front of us, around us, and so we can better plan the order in which, we do construction. And finally, with remote project inspection, VR facilitates remote project inspection and allows stakeholders to virtually inspect construction sites and identify potential issues without being physically present. Now that requires a little different interaction. We can't do all inspections. We need to be on site, but with specific types of inspections, we're able to do that, taking advantage of VR. These are two headsets that I have personal experience with. The upper one here in the upper left, that's an HTC Vive. The one that I have is wireless. The two little boxes you see on both sides of the goggles, those are sensors. They pick up where I'm walking within the building. And then the two devices towards the front of it, those are the devices that you hold in your hand as you walk around so that you can interact with the virtual environment. The lower right is an Oculus Rift, and there's multiple versions of each of these products, but that one is typically wireless. It's a little bit lighter unit, and it has the little handheld units, again, that allows you to interact with the virtual environment. All right, here's the video. I'm not going to play the entire video, but this is me actually showing you the VR experience. And so go ahead and jump ahead here. Now, in the lower right-hand corner, that is me. And I'm actually in a room that we used a lot to simulate AR and VR, and you'll see the green screens in the back. I'm pointing to the upper corners where those little boxes are. And notice when I pick up the headset, how the screen you're looking at shows what I see when I put on that headset. So notice as it's shaking in my hand, you can see that the screen is also shaking. And as I put it down now, I'm actually going to pick up a device that I could use and I hold in my hand, and that'll give me the ability to walk through the building, and I can pick up any item, and I also have the ability to jump to other parts of the building. So here I am putting on the headset, and obviously this building is much bigger than the room that I'm in. So at some point you'll see me kind of jumping. You'll see a little light on the ground, and I'm controlling where I could jump to within this particular building. So I'll make sure I'll go over and I'll pick up my handset. And now I'll walk around and I'll see that there's a little pamphlet here. And using my headset or my hand, I will pick up that uh, that item there, and I'll go ahead and read it, and I can go ahead and put it back. And then you'll see as I walk through. Now you'll notice as I walk towards the camera, I know to stop because in my headset, which you don't see, I see a grid that pops up to let me know that I'm very close to something in that real room. Now you can see I'm just jumping around looking at the exhibit. And here's something I can do that I can't do in the real world. I can actually jump down into the exhibit. And you can see me turn around and look, and I decide I'm going to walk around and take a look at this particular exhibit. This is very easy. It's very fluid for me. And like I said, I never worry about walking into something because the unit will display a blue grid in front of me to let me know that says, hey, don't walk any further. And you'll see as I continue to move around, I'll even walk up to this painting of the Mona Lisa. And depending on the program, here I can see actually some brush strokes, and you can see some of the cracking related to the painting. So here I am just looking around. There's an elevator in here. I could actually take the elevator up to a floor. In this scene, what you're looking at is I'm using a different program. This program actually allows me to jump ahead, and it shows a person. And here I'm actually walking into my office. This is my actual building. And walk down the hall here to my left. This is my actual conference room. That's exactly how we have our tables laid out. And so before we even constructed this space, we decided to design this here using the VR. Took some measurements, which you saw up there at the top. And I'm going to jump ahead a little bit in this video. And here, this is my break area. And it's exactly how it looks in the real world, but I'm 100% in the virtual world. And here I'm just going to jump ahead to different parts of the building. Now we set this up so that the cubicles had transparent walls so we can see a little bit better. But I'll show you one more place in here. That office right there, notice I click on the door, it opened. This actually was the owner's office. And I'll walk back out here into the space. And finally, you'll notice right over here, and I'll pause, back here in the right corner, that was my office. And that's actually where I am today. But this was done, I forget, maybe 4 or 5 years ago. And so we were able to look, before construction started, we were able to design the space and see what it looked like and see how we felt about it before construction ever began. So that's my experience with VR. Here's another personal experience I have with VR. And this is one that really kind of blew my mind when we started doing this. Here is me. Notice my name. That is me right there on that side of the building. To the right of me is Misha. And then the camera point of view is Rick. The three of us were actually in this virtual environment together. And we're all looking at this building that we constructed. Now, what you'll see here in a minute, you'll see a little arrow that points. Misha is going to put himself right into the environment. And me too. You'll see I'll disappear. And all of a sudden, I'm going to show up standing on the sidewalk. And as Rick starts to kind of look around, you can actually see, and I'll bring up the arrow again. And here's Misha and I standing there. Now Rick teleported himself into here. And now you're going to see the three of us, and we are all actually in different parts of the country. Misha's on the West Coast, I'm in Georgia, Rick is in Florida. And this is simulating our bodies. We can each hear each other talking. Our headsets have speakers as well as microphones, so we can talk to each other. When our hands move, our arms move, our head moves in real life, it also moves here in the virtual world. Now you'll see a couple of us are looking down right now, and that's because we just happen to be looking down at a screen. But we'll raise our head, and at some point, what you're going to do is Rick will ask Misha to make some design changes. So you'll see Misha disappear in a second, and then he's gonna get bigger. He's gonna kind of look like a giant. So to the left here, you're gonna see Misha's now going to create some trellises right over here. Notice he's laying out some wood beams here. And notice the devices in his hands for him to lay out those beams. Well, if he's putting out some beams there, maybe he'll put in some columns. So he made himself small again. I happen to be standing underneath so I can see what it looks like from my point of view. And Misha is now putting in a couple columns in here. And very quickly, he's able to put in 2, 3 columns and lay them out. And with me standing right there, I can give him input about what I like and don't like. So that is the collaboration that I was talking about in a previous slide. Okay. Now let's talk about artificial intelligence. Okay. So let's get into it. We've been hearing about AI for quite a long time, all right? And the way Autodesk defines it is the theory and development of computer systems able to perform tasks that normally require human intelligence, and in some cases, can surpass it. So you've probably heard of AI all over the news, and probably the more common one that you may have heard of is ChatGPT. And it's said to be the fastest growing application of all time. I have actually used ChatGPT. When I write long letters or documents, I will put it in ChatGPT and I'll ask ChatGPT to review it, and I'll ask it to check the grammar, and it will come back and it will rewrite it for me. Still my own writing, but it'll rephrase a couple sentences or replace some words that I have missing, and it saves me a great amount of time. And so I use ChatGPT when I want to make sure that whatever I write down, it sounds professional. All right, so now we've all heard, about AI is going to take over the world. Robots are going to take over the world. I consider AI kind of like social media today. It has its strengths, it has its weaknesses, it's good, it's bad. Unfortunately, the development of AI is not going to stop. So it's important that we all become familiar with what AI is so we better understand it and then we know how to utilize it. A little quick here, and I'm going to rush through this as far as history. When did AI first happen? Well, some people say that it happened back in 1956 when IBM started working on a computer. And then in 1977, IBM's computer beat a Russian chess player in a chess match. And so the computer had to think of different scenarios and where it wanted to move. So it's been around, actually quite a long time, but it is quite a bit different today than it was many years ago. I will mention this. Autodesk has been involved with AI for a very long time. In 2009, they published a paper called Physics-Based Generative Design. I'm going to rush through this because I know I'm running out of time and I want to give you some examples. But in 2017, they first published their research paper on generative AI. And then in 2018, they officially established an AI lab to conduct fundamental and applied research in AI and machine learning. But we've all been using AI lately. And so let me give you examples of it. Now, Autodesk did form the Autodesk AI. So they're utilizing AI to automate tedious and repetitive tasks. But let's talk about some of the programs that use AI. All right. So we know it has enormous potential. So let's actually take a look at some of that. And I'm going to just jump ahead to these examples. Forma. This is a big deal. The project was the Rapid Operational Energy Analysis. On the right-hand side, what you're looking at, AI took the space that was available and it started coming up with different scenarios for buildings. And it not only was it trying to fit in the buildings, it's also trying to fit in the parking. And it's also running different analysis, determining the window to wall ratio, the roof and the wall construction. It's also determining the energy that the building would require. So it's doing all this very, very quickly. Construction IQ. For those of you that have been using the Autodesk Construction Cloud, we are gathering information during construction that it's able to identify, it's able to make decisions for us. And in this case here, it's letting us know if there's any high-risk subcontractors, high-risk issues, high water risk issues, overdue issues. It's actually determining all that using something called Construction IQ. Within Autodesk Build, as we take photos, it will automatically tag the photos. So later I could search and say, show me all the photos that have people in them. In fact, what's interesting about people, I took some photos that I didn't know there were people in the photo. They were just kind of off to the side. One was partially behind the wall. And when I looked at the tags said things like concrete, walls, columns, people. And I thought, where are people? And sure enough, there was just part of people showing up in different parts of the photo. But then it allows us to filter out the photos and find specific photos. So I can find all the photos that have specific tags in them. Auto specs. All right, there's two products related to auto specs. There's the Autodesk Construction Cloud Auto Spec, and there's Pipe Auto Spec. If you haven't seen this product, it's pretty incredible. You can take a spec book that has hundreds of pages, bring it into auto specs, and it will extract out all the submittal items, and it will generate a submittal log for the general contractor, from which then they can assign to specific responsible contractors. Something that used to take a project engineer weeks to do and possibly make mistakes, auto specs can do that very, very quickly. Autodesk Takeoff, they have a symbol detection tool. You notice on here, if I wanted to count all of these diffusers that are blue, I could do this manually, or I could select one of them and then tell the software to find all similar diffusers. And not only will it identify all of them, it'll also label them and it'll color them to let me know that they've been identified. So real quick there, guys, each one of these comments, we could have spent an entire hour on just one of the items, whether it was about robots, AI, AR, VR, but hopefully I kind of gave you an overview to let you know the potential that is out there. And feel free, if you have any questions, I'll be happy to answer them either by email or live during our session. Thank you.
All right, guys. Thanks. Sorry about the beginning there. Didn't realize my microphone was on mute. I did want to share a couple things. Number one, I'd asked the question, what you guys were most interested in seeing on the future ones. Was it AR, VR, AI, robots? We can't get into a lot of details in one session when we have so many different topics to talk about. So definitely, that's something we want to hear about from you if you want to hear more about a specific topic. But I did ask a question about, science fiction, Star Trek, Star Wars. The reason I asked that is because, I grew up first watching Star Trek, the reruns. I was born watching reruns, and then Star Wars is more of my generation. But one thing I wanted to mention is just the science fiction and the technology. Science fiction kind of leads us towards all of this, the AI, the AI, AR, VR. And I'll give you a good example. If you look back at the old Star Trek shows, going back to the 60s, the captain of the Enterprise was named Captain Kirk. And when he was on a planet, he would call up to the ship and he would use a device and he would flip it open and he would say, "Beam me up, Scotty." Well, what you're looking at here is a cell phone. This is an old style cell phone, just a flip phone. And that flip phone, was first brought up in the 60s. And we never even thought about carrying cell phones. In the 90s, things got a little bit more advanced, again, watching Star Trek and Star Wars, where people were using digital flat screens for things, and then in the 90s, there's this thing called the Palm Pilot. And we had this for many years. many of us, the firm I was at, we had these different Palm Pilots, which, today was the predecessor to carrying iPhones. And so, we're using the iPhones today. We're using Android phones that have some sort of integration with AI and VR and AR that, I would encourage you guys to embrace it. Because it's coming, it's not stopping. The technology is changing quicker and quicker. But we're also available to help you guys utilize that, at least in the construction industry or the design industry as well. So, if you guys have any questions, go ahead and put them in the chat. Otherwise, I know we've got some other sessions immediately following, but I'm thank you for joining, and we look forward to hearing back from you guys. And I'll just keep this open for just another minute. And if I don't see any other questions, then we'll go ahead and close and stop the streaming. All right, David, thank you. I'm glad you enjoyed it. By the way, guys, real quick, that video that you saw where I was inside of the VR environment, the software that we used was called The Wild. And so if you want to see or hear more about it, just Google The Wild, and you guys can see demos of that in action as well. So, what do you think about what do you think will benefit the construction industry more, AI or VR? All right, I think VR is going to benefit more on the design side. Although, my first experience with VR at AU, we put on the goggles and there was a car, and I was able to go to the car and I could push and pull and change the car. I think on the construction side, I think AI will have a bigger impact, because today guys are putting on the goggles. They're clear lenses, and so, like I said, you can put those on and you can walk the job site and literally see where everything is supposed to be if it's not already there. And then the other thing we're using with it is you can look at equipment and you can get all the information about that equipment right there with your AR goggles. So I think AR is going to have a bigger impact on VR. So cool. Thanks, Lee. Glad you enjoyed it. And glad to share some of my personal experience. It's not until I look back on it that I forgot some about the stuff I did, like that one video where I'm holding the furniture on my hand. I completely forgot about that, but I'm glad you guys enjoyed it. Cool. All right, guys, I don't see any other questions, so thanks for joining, and we look forward to future time with you guys. Thank you. Great. Thanks, Abraham. Bye, guys.